This is a video going over the practice questions for Unit 0, the first unit in the AP Chemistry course here. So I'm going to go over each of the questions with you, and if you have any additional questions, you can ask me. You can send me a message on Edmodo, etc. But these are I'm just going to kind of explain each of the questions and each of the answers. So first of all, for this first section, and I'm not very clear about this, but on questions 1 through 5, the answer is one of those A, B, C, or D. So on question number 1, if you think the answer is oxygen, you don't say O, you say A, etc. So for each question of these first 5 will be one of these 4 choices up here. So number 1 says, identify the charge of each of the following elements when forming a solution. Now, again, I just kind of threw that question in there. That's not a multiple choice question. For each one of them, I want to know the charge. So when you look at the periodic table, you can see that oxygen is 2 to the left of the noble gases. So oxygen is O2 minus. Phosphorus is 1 more over, so phosphorus is P3 minus. Sodium needs to lose 1 electron to become like a noble gas, so it is Na+. And then krypton, because it is a noble gas, has no charge associated with it. It would not have a charge at all. Okay, so those are the charges of each of those elements. For question number 2, it said, would most likely be X in the formula AlXO4. With a question like this, you want to think about your polyatomic ions. Okay? For example, this has got to be Al and then obviously something O4. So when I think about the 12 polyatomic ions that we had to know, I'm thinking of it could be AlSO4, because that would be aluminum sulfate. The only problem with that, A, is that sulfur is not one of the choices up here, and B, the charges don't line up. So if we're creating AlSO4, aluminum has a +3 charge, sulfate has a -2 charge. The formula for aluminum sulfate is not AlSO4, it would be Al2SO4 3. Okay, so sulfur doesn't work because A, it's not one of the choices, B, because that would not be the right formula. So is there another polyatomic ion that we've learned that also ends in O4? Well, there's sulfate, there's nitrate, there's acetate, there's perchlorate, which again could be ClO4. But again, chlorine is not one of our choices. And even if it was, chlorate has a -1 charge. So let's think about what that would be. Still aluminum's 3+, perchlorate is -1. That would have to be Al parentheses ClO4 3, which again, that's not the formula that they give us here. So it can't be perchlorate either. So we just kind of keep thinking there and really use these up here to help you. Well, is there an OO4? No. Is there a KRO4? No. Is there a sodium O4? No. But there is a PO4. Al3+ and PO4 3- is going to create the formula AlPO4. And again, that's our formula. So number 2 has to be B. And again, be careful. Don't write P as the answer because it's either A, B, C, or D. Write P, or write B as the answer, which is P phosphorus. Okay, number 3 says identify the element that exists in nature as a diatomic molecule. I'm not sure how much this came up in class, but again, we do have, and this is in your notes, whether we brought it up in class or not, there is the good old-fashioned Brinkelhoff. Okay, and Brinkelhoff, sorry, that's a chlorine there. Brinkelhoff are the elements that when they're by themselves exist as Br2, N2, O2, etc. And what those are called is those are called diatomic, di meaning 2, atomic meaning atom. So it's a 2-atom molecule. So notice that there's 2 atoms in this molecule. Okay, so in this case, the correct answer, the only one of the Brinkelhoff elements that's up here is A. So number 3 is A. Okay, number 4, can form an ionic compound, so ionic means ions, with a single magnesium ion. So the first thing I think is, okay, what is a magnesium ion? Well, a magnesium ion is Mg2+, and you have to form an ionic compound. So I know an ionic compound, something has to have a negative charge. Well, again, that immediately takes out krypton. That immediately takes out sodium because krypton has no charge and sodium has a positive charge. So it's either O or P, either A or B. So if I chose, let's just say I randomly choose phosphorus, I know that phosphorus is P3-. And the formula for that would therefore be Mg3P2. Okay, but it says a single, that means one magnesium ion. That's not one magnesium ion, that's 3 magnesium ions. So phosphorus does not work. Now, why does oxygen work? Well, let's just look. If oxygen's -2, magnesium's +2, what's the formula going to be? Just MgO. And so I am forming an ionic compound with a single magnesium ion. Now, oxygen isn't the only element that could do that. I mean, for example, chlorine is Cl-. Okay, well, if I form an ionic compound between magnesium and chlorine, that's obviously going to be MgCl2. Well, MgCl2 still is a single magnesium ion, so therefore that one, chlorine, which obviously is not one of the choices because then you'd have 2 right answers, chlorine would also give you a correct response to number 4 if that were an option. Obviously it's not. Number 4 is A. Okay, so let's go to number 5 then, very similar to number 4. But now it's saying we'll form an ionic compound with a single nitrate ion. Well, nitrate is NO3-. So again, let's look at our choices here. With NO3-, we know that obviously whatever it combines with has to have a positive charge. Well, this one's really easy because krypton, no charge, negative charge, negative charge. It has to be sodium. Now, let's pretend that this is a little bit more challenging. Let's say that magnesium was one of the choices. Okay? Only one of those is correct. Well, we already know sodium's right. But why would magnesium be wrong? Because when magnesium forms a compound with nitrate, that +2 is going to make NO3, 2. And again, now it's not a single nitrate ion. Now there are 2 nitrate ions, meaning that magnesium would not be a correct response to number 5. Okay, but obviously sodium is our only choice, so it has to be C. Okay, let's look at question number 6. It says an elemental ion has 36 protons, 36 electrons, and 44 neutrons. What element is it? So first of all, let's focus on the protons. Okay, this is one of those questions too where you really want to just get rid of some answers, and then whatever's left, that's the right answer. So first of all, 36 protons, remember that bottom number here is the atomic number. So 34, wrong, can't be A. 34, wrong, can't be D. Oh, and 34, wrong, can't be C. Okay? Now, clearly our answer, we're left with just B based on the protons alone, but on the test it might be a little bit more challenging. Notice that the protons and the electrons are the same, which means that this, whatever this representation is, it can't have a charge up in the corner because the number of protons and the number of electrons are equal to each other. So again, that takes out A again because there can't be a charge, and it also takes out C again because again there can't be a charge. Okay, and then our last thing, if that doesn't tell us the answer, then we also know we can add the protons and the neutrons together. 36 plus 44 equals 80, which means the mass of this atom has to be 80. So once again, 78, 78, 78. Again, all of those are wrong. The only one with a mass of 80 is B. So check the protons first. Then check the charge if the protons and electrons are the same. If it were like 36 protons and 38 electrons, then A is now back in the running. Okay, A is out for other reasons, but A is the only one that has that -2 charge, which is what that would give you. Okay, but obviously the way that it's written, B is the correct response. Okay, number 7, significant figures. Remember that with significant figures, there's 2 times when zeros are not significant. When they're leading zeros, those zeros are not significant. Okay, and if a number ends in zeros that are, again, whole numbers to the left of the decimal point, like 4,500, those zeros are not significant. Every other time they are. So, for example, if I have 0.000450, that 0 is not one of those 2 cases. Okay, these are only 2 cases when they're not. So that's not one of those cases, so it is. Okay, even this number here, the 4,500, if I put a decimal point at the end, now those zeros are significant. Only when it's a whole number without a decimal point. Okay, those zeros are not significant, and then obviously our leading zeros here are not. Okay, so on letter A, when we look at scientific notation, the only number we look at is right here. That only has 1 significant figure, so nope, it doesn't have 3. On letter B, that 0 is a leading 0, so it is not significant, so this one only has 1, 2, 3, so that one's wrong. 2038, 2038, 1, 2, 3, 4, nope, that 0 is between the 2 and the 3, and again, it's not one of our 2 times. But letter D, leading zeros don't count, so 1, 2, 3, letter D is correct. Okay, number 8. An object will sink in a liquid if the density of the object is greater than that of the liquid. If the mass of an object is 87.5 grams, what volume must it have in order for it to float in liquid mercury? So first of all, let's figure out what they're talking about here. The mass is 87.5, and they give us the density. So right away, I know the mass, I know the density. What am I missing? The volume. So first of all, volume equals, I can't remember. If I can't remember, what do? I look at the formula, density, mass, volume. How do I find volume? It is mass over density. So volume is mass over density. And again, they give us the mass of 87.5 grams. We divide that by 18.6 grams per cubic centimeter. And now we're going to need a calculator. So I'm going to grab my calculator. 87.5 divided by 18.6 equals 4.70. Significant figure-wise, they both have 3. So 4.70. And again, I could put cubic centimeters here. I could also put milliliters. We know they are the same thing. Now, here's the thinking part. We know that it's 4.7. But is it more than 4.7, less than 4.7, or equal to 4.7? So let's think about this. An object will sink in a liquid if the density is greater than that of the liquid. Okay, we know the density is 18.6. So they want the object to float. So we need the density to be less than 18.6. So let's think about this. If we have 87.5, that's the mass. We know that density equals mass over volume. If we have the mass and the volume is 4.70, again, it's going to be close to that, but it's not going to be exactly that. Okay, cubic centimeters. And we need the number to be a little bit less than 18.6. You have to ask yourself, what does this number need to be? Does this number here need to get bigger? Does it need to get smaller? Or does it need to remain the same for 18.6 to be smaller? Okay? And hopefully you can see, well, wait a minute, in a fraction, to make my answer smaller, the denominator has to be bigger. 87.5 divided by 5 is less than 18.6. So to make an answer smaller, your denominator has to get bigger. So therefore, you have to be more than 4.70. Okay, and that is the correct answer on number 8. Okay, number 9. And at any point, if you're not understanding something, you always have the option to stop this, back it up, and listen to it again. Okay, measured mass of an unreacted metal was dropped into a small graduated cylinder half filled with water. The following measurements are made. So the mass of the metal, so here's our graduated cylinder here. We've got a piece of metal we put in there, and it is 43.285 grams. So the water was at 13.8, and now it's gone up to 16.2. Okay, and this is, I don't think I give you, I don't give you choice on this. So this is a significant figure question. It's not that difficult, but it's really easy to mess up your significant figures. So first of all, we know the mass of the metal. We just need to know the volume of the metal. So, well, we can use that by using water displacement. The water was at 13.8, and then when you put the metal in there, it went up to 16.2. So the first thing we're going to do, we're going to take 16.2 minus 13.8. And the reason I'm showing this separately is because we're going to look at significant figures here when we're done. 16.2 minus 13.8 is 2.4 milliliters. Okay, and again, this is one of those times where we're switching rules in the middle, because now we're going to take 43.285 grams. We're going to divide by 2.4 milliliters, and notice one number after the decimal point, one number after the decimal point, one number after the decimal point. But now that I'm dividing, now I look at the whole number. This has 5 significant figures. This only has 2. So therefore, my answer can also only have 2. So 43.285 divided by 2.4 equals 18 grams per milliliter. Okay? And that's what I'm going to report. That's my final answer is 18. Okay, number 10. Very similar to number 9. Same idea here. You'll notice that every single answer is the same. The only question is how many significant figures go in your final answer. So the first thing we're going to do, mass of the empty container and the mass of the container plus the solid, is we have to figure out what's the mass of the solid. So I'm going to take 107.0 minus 8.0, and that's going to give me 99. Now, when I see 99 on my calculator, that's all my calculator shows, 107 minus 8 equals exactly 99. Okay, but then I have to think, this has one after, this has one after. Oh, so does my answer. Even though my calculator doesn't show it, it is 99.0 grams. And then obviously that's the mass. I'm going to divide by the volume, 11.0 cubic centimeters. Now I'm looking at the whole number. This has 3 significant figures. This has 3 significant figures. Therefore, my answer, 3. Again, your calculator's not going to show it, but your answer must have 3 significant figures. So C is the correct response. Okay, number 11, which is not correctly represented by the right number of significant figures. So these are a little bit tricky, but here we've got parentheses. So let's go 2.45 divided by 2.0 equals 1.225. Now again, we're switching rules, so we're going to use the division rule first. So this has 2 significant figures, so that becomes, instead of 1.225, just 1.2 minus 0.5 equals 0.7. Okay, and that is correct. 1 after the decimal point, 1 after the decimal point. Letter A is correct. Okay, letter B. Oh, gosh. So 2.7 divided by 3 equals 0.9. But again, I have to look at the whole thing. 2.7 has 3. 3.00 has 3. So that's actually 0.900 minus, right, subtract 2.0 equals negative 1.1. Now we're thinking, okay, 3 after the decimal point, 1 after the decimal point. I can only have 1 after the decimal point, so negative 1.1. Now we're going back to multiplication. Gosh, this is a little tricky. This has 2 significant figures. This has 3. So therefore, my answer can only have 2. And notice that in their answer, they have 3. So letter B is incorrect. Okay? And that's what they want, is not correctly represented. Okay, and then letter C, you're just subtracting. This has 2 after the decimal point. This has 3. So my answer can only have 2. So C is correct. And then D, division, 2 significant figures, 2 significant figures. My answer has 2, so I'm fine. Okay, number 12. Whenever you see a problem like this, I feel like it's really helpful if you can kind of draw something out. Kind of like I did, I don't know if I erased it, but on here, even though it's pretty simple, I kind of drew something out there to kind of help me. And on number 12, I think especially with all these numbers, it helps to draw something out. So it says an 85.20 gram sample of zinc. So it's placed in a flask. So I'm going to draw my flask. Okay. And I'm going to put a piece of zinc in there. Zinc. And I'm going to say mass equals 85.20 grams. Okay, water, in which the solid is insoluble, which means it doesn't dissolve in it, is added to the flask. So the total volume of the zinc and the water is 98.23. So I'm going to put some water in here. And I'm going to say volume of zinc plus water equals 98.23 milliliters. Okay. And then again, the mass, it tells us the zinc and the water together have a mass. So the mass of the zinc plus the water equals 116.20. Now, I don't know if this is going to help me or not, but right away, as soon as I wrote that down, I thought to myself, wait a minute, they're telling us the mass of the zinc. They've already told us that. It's 85.20. And if I know the mass of the zinc and the water together, I'm not even going to read the rest of the problem yet, but I'm going to figure out the mass of the H2O must equal 116.20, and I'm doing this on my calculator right now, 116.20 minus 85.20. And again, significant figures, if I'm subtracting, is not 31. It should be 31.00 grams. Well, you might not need that, I know, but it was really simple, and I thought, well, clearly I think they're kind of leading me in that direction anyway. Okay, and then it tells us that the density of the water, so density of H2O equals 0.9668 grams per milliliter. Okay, and now they want to know what is the density of the solid zinc. Well, I know that density of zinc equals the mass of the zinc over the volume of the zinc. Well, and I know the mass of the zinc. They told us that in the problem. It's 85.20. So density is going to equal 85.20 over the volume of the zinc. Now that I don't have. So here comes the thinking part. We have the total volume right here, 98.23. If I could subtract the volume of the water, that would leave me with just the volume of the zinc. Because remember, that's what I need. I need that volume of zinc to get the density of the zinc. So I've got to do some work here. So I've got the total volume again, and to get the volume of just the zinc, I have to subtract the water volume. But I don't know the water volume. I just know the total volume. But I do know the density of the water. And oh, hey, remember earlier when I calculated the mass of the water? If I know the density of the water and the mass of the water, can't I find the volume of the water? Where volume of H2O equals the mass of H2O over the density of H2O. So 31.00 grams over 0.9668 grams per milliliter should give me the volume of water. So 31.00 divided by 0.9668. And again, I'm trying to carry through my significant figures here. I get an answer of 32, and again, both of these have 4 significant figures, 32.06 milliliters. And again, that is of just water. I use the mass of water and density of water. That gives me the volume of water. Okay, well, if I have 32.06 milliliters of water and I know the total volume again is at 98.23, I should just be able to take 98.23 and subtract 32.06, and that gives me a volume of zinc equal to 66.17 milliliters, which means I substitute that number right in here, 66.17 milliliters, and now I can just solve and get my answer. So 85.20 minus 66.17 equals, I hit subtract instead of divide, that's great, 1.2, and I'm going out 4 significant figures here, so 1.288 grams per milliliter is now my final answer. Okay, now that's a tough question. It's not really that tough, but there's a lot to do in that problem. So again, don't try to go right from step 1 to step 5 or whatever. Okay, when you do a problem like this, don't try to do the whole thing all at once. Just go step by step, like I did. When I saw that mass of the zinc, and then I saw the total mass, I went, well, wait a minute, of course, I can get the mass of the water by subtracting those two. Okay, and I wasn't trying to do the whole thing all at once, and that's a big thing on the AP exam, is you see a question and you're like, well, I don't know how to do it, but I do know how to do this first step. Well, a lot of times by doing the first step, it leads you to the second step, which leads you to the third step, etc., until all of a sudden you've got the answer, and you're like, wow, I couldn't have done that without doing all of the individual steps. So on the AP test, don't try to immediately figure out the density of the solid. Just do what you have been taught to do, and it will lead you down that path to what they're asking you for. Okay, number 13, let's finish this up here. Question number 13 talks about writing formulas for the following compounds. Now, it could be ionic, could be covalent, it could also be acids. But let's look here at the first one. So again, the first thing I do is I always try to categorize, is it ionic or is it covalent or is it an acid? So the first one, I see sodium and I see fluoride. I think, oh, metal, non-metal, that has to be ionic. If it's ionic, I have to think about charges. Sodium is Na+, fluorine is F-. So there's a 1 and a 1, so therefore the formula is just a simple NaF. Okay, the second one, copper, metal, hydroxide, nonmetals, so therefore also ionic. So copper with a Roman numeral 2 tells us that copper has a +2 charge. Hydroxide, because I've memorized it, is OH-. So this 2 needs to come down here. So it is CuOH. Don't forget the parentheses on hydroxide. If you don't put it on there, you will be marked off on my tests and certainly on the AP tests as well. Okay, the third one, dichlorine, nonmetal, oxide, nonmetal. Oh, this is a covalent one, so all I have to focus on are those prefixes. So dichlorine means there are 2 chlorines. Make sure you write it that way. Don't put the 2 in the front. And heptoxide means there's 7 oxygens. Okay, Cl2O7. Don't ever write it like this, 2Cl7O. You don't ever write formulas like that. Okay, the number always comes after, and it's a subscript. It's that little number down in the corner. Okay, molecular oxygen. What the heck is molecular oxygen? Well, molecular means a molecule. So if it's molecular oxygen, it's oxygen when it's a molecule. If I were to say, for example, atomic oxygen, that means an atom of oxygen. Atomic oxygen is just O. Okay, that's an atom of oxygen. But when I say molecular oxygen, that means a molecule of oxygen. And because oxygen is a diatomic molecule, as we talked about way back here at the beginning when we were talking about Brinkelhoff. I think I might have erased it, but when we're talking about that, we know that oxygen, when it's by itself, there's always two of them. So that is molecular oxygen. Okay, last one on this column, iron 3 phosphate, metal, nonmetals. Oh, it's ionic. I have to take into account charges. So iron has the +3 charge because that's what the Roman numeral says. Phosphate is PO4 3-. Oh, +3 -3, they cancel each other out. So it's just Fe, or not F3, FePO4. That's an E, FePO4. Okay, the right column, let's look at those ones. Potassium sulfide, metal, nonmetal, so it's ionic. Potassium is +1. Sulfur has a -2 charge, so that 2 has to come down here, making it K2S. Okay, silver sulfate, silver metal, sulfate nonmetal. So therefore, another ionic one. Remember, silver is one of those three. Aluminum's +3. Zinc is always +2, and silver is always +1. So Ag plus and SO4 2-. That 2 has to come down here. Ag2 SO4. Okay, so silver sulfate is Ag2 SO4. Okay, the next one, hydrochloric acid. When you see an acid and it starts with hydro, you know that it's a binary acid. There's no oxygen in it, which means it just comes from chlorine. Chlorine has a -1 charge, so when it forms an acid, you need one hydrogen to cancel that -1 charge. So hydrochloric acid is HCl. Again, no oxygen because it starts with hydro. That's your giveaway there. On the next one, though, there is no hydro, which means there is oxygen in it, okay, which leads us to sulfuric acid. Remember, if it ends in IC, sulfuric, it came from ATE, which in this case is sulfate. And sulfate is SO4 2-. If it has a -2 charge, it means you need 2 hydrogens in the front, so it is just H2SO4. And then our last one, nonmetal, so it is covalent. So we only look at that prefix. There is no prefix here, which means there's 1 carbon, and mono is 1, so it's just CO for carbon monoxide. Okay, and then our last question here, number 14, says write the names for the following compounds. And again, this comes back to, obviously, the polyatomic ions. Do you know the names of them? So magnesium, not a transition metal. So it's just magnesium. And CO3 is the name of carbonate. So it's just magnesium carbonate. Okay, magnesium's a metal, carbonate's nonmetals. So obviously that's an ionic compound. No prefix is needed. Magnesium carbonate is our final answer. Okay, the next one, N3O5, nonmetal. So it is covalent, so we do have to use prefixes. Because there are 3 nitrogen, it's trinitrogen. And then 5 oxygens. And again, whether you leave that A in there or not, sometimes I do, sometimes I don't. Pentaoxide or just pentaoxide, either of those would be fine. So trinitrogen, pentaoxide gives you N3O5. Okay, the next one, LiCl. Lithium is a metal. Chlorine is a nonmetal, so it is ionic. So no prefix is needed. And chlorine just becomes chloride. So that is just lithium chloride. Okay. The next one, Ni parentheses OH2. Ni is obviously nickel. And as soon as you write that down, you go, oh, that's a transition metal, and it's not aluminum, zinc, or silver. So I have to use Roman numerals here. Hydroxide has a -1 charge, but there's 2 of them. So that means overall this has a -2 charge, which means nickel needs to have a +2 charge. So it is just called nickel 2 hydroxide. Okay, the next one, CH4. From what we've learned in class, because they're both nonmetals, we're going to call that carbon tetrahydride. Someday when you take organic chemistry, you're going to learn that the more common name of that is methane. Again, not something that you need to know now, but that is, you will hear that. That is one of the main gases in natural gas, and very, very commonly found in different gases that we use in our real life. Okay, next one, NH42SO4. NH4 is the only positive polyatomic ion that we have in our list of 12. And we know that the name of that is ammonium, not ammonia, very different. Ammonium is NH4, and then SO4 is sulfate. So that is just ammonium sulfate. Notice we don't put diammonium sulfate. It's not a covalent compound. It is an ionic compound. You've got a positively charged ion and a negatively charged ion. So that is, you would never use a prefix on that. Okay, the next one is H3PO3. So to me, that looks a lot like PO4, and I remember that PO4 is phosphate. And remember, like we saw earlier, if it ends in IC, it becomes 8. Or backwards, if it's 8 and you're making the acid, it becomes ic. Okay, we also know that if it has one less oxygen, instead of PO4, phosphate, it's PO3, again, same charge. Instead of phosphate, it's phosphite. And if it ends in ITE, it becomes OUS in the acid form. So instead of phosphoric acid, this is phosphorus acid. So H3PO3 is phosphorus acid, where H3PO4 is phosphoric acid. Okay, and that kind of leads us to this next question. MN3PO3 2 is same thing. Instead of PO4, it's PO3. And again, that is phosphite. Now, it's not an acid, so we don't have to worry about this part. But we do need to remember that if it has one less oxygen, that we change that ATE to ITE. So Mn is manganese. That's an S, manganese. And PO3 is phosphite. But again, we have to remember that manganese is a transition metal. So remember that this 3 came from here, which means this 2 came from here. And the Roman numeral, remember, tells you the charge. So that is manganese 2 phosphite. Okay, and then we've got HgO. Again, we've got another transition metal here. Hg is mercury. Oxygen, obviously, is oxide. Oxygen has a -2 charge, which means the mercury has to have a +2 charge. So that is mercury 2 oxide. Okay, and then our last one, again, one more transition metal, iron, and then HCO3. Again, you can call that hydrogen carbonate. You can also call it bicarbonate. I write bicarbonate just because I'm lazy and don't want to write out hydrogen. And notice that bicarbonate, if you remember correctly, does have a charge of -1, but there's 2 of them. So that means overall that one's -2, which means the iron must be +2. So we have to put that in Roman numerals. So that is iron 2 carbonate.